Question 5 in the 2023 Higher Applications of Maths past paper. Right at the top here, we've been told to refer to a CSV file and to answer in a Word doc. We've been told to use the appropriate statistical software and to include all output from the statistical software and our answers in the doc. So no written answers here. So we've got a specialist coffee shop sells 22 different drinks. For each drink, the following data are provided: carbohydrate contents in grams and the number of calories in kcals. The number of calories is dependent on the carbohydrate content of the drink. And then we've been told to construct a scatter plot on number of calories on carbohydrate content. The number of calories is dependent on the carbohydrate content. This means the carbohydrate content will need to go along the x-axis. So I go over to RStudio. I've got my working directory set. I can see my CSV file. So I'm going to read in the data set. And run that line of code. Down the bottom, that's read fine. I'm going to attach my variable names and head my data. Just have a look at the first few. So we've got the drinks, we've got the number of calories, we've got the carbohydrate content. 22 observations. If we look back to the question, 22 different drinks. Calories on carbohydrate. Calories is the dependent variable, so that will need to go along the y-axis. So calories along the y. So this means my plot will have the carbohydrate content along the x and the number of calories along the y. Main equals, this is me adding a title, and the wording, if we go back to the question, was calories on carbohydrates. So calories on carbohydrates. Right, here we can see our scatter plot. I'm going to export that as an image. I'm going to copy my image. And I'm going to go to my Word doc. Statistical software output. I'm just going to paste that in there. I'm working on Google Docs. This will be done in Microsoft Word when you're working on a desktop. Right, part B. Find the correlation coefficient between the calories and the carbohydrate content. It's basically asking how strong is that relationship. There are two ways we can do this. Core.test is the formula that's listed in your SQA formula list. Carbohydrate content, comma, number of calories. It's run the Pearson's product moment correlation test. If we look at our answer sheet, we've got a box for our statistical software output. So we would copy all of that and paste it into the box, just like so. We then actually need to answer the question. And the question was, find the correlation coefficient. We call that R equals 0.96. So I've just rounded that off sensibly. It's not enough just to have that there. What you could do, it's not written in the formula list, but you could use this line of code. You could go core bracket carbohydrate content number of calories and run that. And it's generated the same result there. You just make sure to highlight that output, maybe even the line of code above, and paste that across. The SQL would be perfectly happy with you generating that. Interpret the correlation coefficient. So we've got a value really close to +1. So we have got a strong positive linear relationship. And that's for 1 mark. You need to mention it's positive and linear, and I would assume they would want strong as well. Just knowing that that's fairly close to 1. Anything above 0.75, we would say strong. Question C. Find the equation of the regression line of number of calories on carbohydrate content. So that is wanting us to say what the equation of the line of best fit here would be. I've got my formula list. So this is quite a complicated formula. I am looking to my correlation and regression. LM y tilde x fits the line. So what that means is it fits the line, but it doesn't draw it. So this line of code here, where we've got y on x, means we need to put number of calories first, because that is on the y-axis. Tilde, so that wavy symbol, not a dash, carbohydrate content. Now, it hasn't added the line of best fit. We've not been asked to do that. Adding the line of best fit would be this line of code I am typing in to line 8. So we've got a line of best fit, but what we've been asked for is line 7 to actually come up with the equation. So I've got my statistical software output. I'll pop that in the box there. The formatting's went a bit weird. The question C's here, but my answer's over the page. It's the SQA's job to interpret that. You don't need to worry about the formatting. We have got the gradient, or the slope, under carbohydrate content, and the intercept. This is where this would cross the y-axis. So our equation is y equals 4.65x plus 73.65. B part 2, interpret the slope and intercept parameters. So it's basically asking us, what does this 4.65 mean, and what does this 73.65 mean in the context of the question? So if we have a look at our scatter graph here, we've got carbohydrate content along the bottom. The carbohydrate content was measured in grams. So our slope, this second variable, slope means for every extra gram of carbohydrate, the drink has an extra 4.65 kcals of calories. The intercept, remember the intercept would be where the line crosses over when carbohydrate content is 0. So we can say that. So when carbohydrate content is 0, intercept tells us that a drink with 0 carbohydrate content would have 73.65 kcal of calories. So your slope is basically telling you how much your line increases for every increment you go across. The intercept is basically telling us what we would have if our x value was set to 0. Right, question D. Estimate the number of calories in which a drink has 59 grams of carbohydrate. So we have got the equation of the line of best fit, y equals 4.65x plus 73.65. The carbohydrate content was on the x-axis, so we can replace the x with the value, just double check, 59, and add on 73.65. Now we'll go to our calculator and type that in. 4.65 times 59, add 73.65, gives us an estimate of 348 kilocalories, or however we say that. You could use RStudio to do that. So you've got a line of code. It's a quite intimidating line of code, but it would look like this. Predict using a linear model of y upon x. So number of calories tilde carbohydrate content bracket new data equals data dot frame. We want the carbohydrate content to equal, double check, I think it was 59. Yep, 59. And that is inside a set of brackets, comma, interval equals pred. And run that line of code. Now, what it's done is it's given us the best fit lines prediction. It's then given us our lower and upper sort of confidence intervals there. But all we would need to do, I mean, the question is worth 1 mark. So really copying and pasting your answer across like so would get you the mark. You should probably put the code in as well, now I think about it, because they always like you to show the code you've used. But for 1 mark, it's probably not necessary. So you don't need to do both of those, either would do. Either use your line of best fit in a calculator, or use RStudio to actually predict.